So remember we were practicing anti-derivatives. Let's just practice one more. I'm going to put up an assignment this week. Actually, I'll probably put it up tomorrow, just so you're alert. Okay? What did I just say? There's going to be an assignment that'll probably go up tomorrow. Okay. There you go. Let's see if you can do that. All right, that's long enough. Okay, we didn't see one that looked like this, but just do the division first. Let's make that 8 over x minus 2 plus 7x squared dx. This, of course, assumes that x is not 0. So I took each term and I separately divided it by x. So I get 8 over x, then 2x over x is just 2, and then 7x cubed over x is just x squared. And now if you do the integral, you get 8 natural log of x minus 2x plus 7x cubed over 3 plus that annoying constant. Now remember what I told you about the constant. The constant stands for the fact that if you took the derivative of this equation, this lower equation, you would get what's inside the integral because the derivative of a constant is always 0. So it doesn't really matter what the constant is. So another type of equation that the problem we give you is something called an initial condition. So an initial condition, it doesn't have to be initial, by the way, but it means that I give you f of 0 equals something. And that helps you figure out what the constant is. Initial times 0. So for example, right, it doesn't actually have to be 0. It could be f at any constant. We'll call that a instead of 0. Suppose I told you that f prime of x is x squared minus 4, and f at 0 equals 7, find f of x. So we have to do 2 steps. First, we do the antiderivative. So we would say f of x is the integral of x squared minus 4 dx. So remember the rule. Add 1 to the power, divide by the new power. And 4 is a constant, so that's just 4x. I'm getting feedback there from the being too close to the blackboard. That's a C with my high-quality handwriting. Okay? Now we can solve for C. Because since f of 0 is 7, we know that 7 is 0 cubed over 3 minus 4 times 0 plus the constant. These are 0, so that means the constant is 7. Therefore, f of x is x cubed over 3 minus 4x plus 7. All right, let's practice a couple. And we're going to do some applications. So let's do this one. Okay, so there's 3 to practice for a minute. So you want to do the antiderivative, and then you take the initial condition and figure out what the constant is. let's take these on. So each of these is the same thing. You're going to do the antiderivative, you're going to integrate, then you're going to use the information that f of 1 is 9 to figure out what the constant is. So the antiderivative of 6x squared minus 4x plus 2 is 6x cubed over 3 minus 4x squared over 2 plus 2x plus c, which simplifies to 2x cubed minus 2x squared plus 2x plus c. And then I tell you f of 1 is 9. So if f of 1 is 9, then I know 9 is 2 times 1 cubed, which is 2, minus 2 times 1 squared, which is 2, plus 2 plus c, so c equals 7. Okay? Won't give you a hard number to plug in. Therefore, if c equals 7, then our equation is 2x cubed minus 2x squared plus 2x plus 7. Okay? Yes?
Use minus the 9 by the
Right. Because 9 is 2 plus c, so c is 7. Yes? This is chapter 4.1. All right, let's do the second one. Same idea. So we want to find the integral of 5 e to the 2x, which if you remember from last time, that's 5 e to the 2x over 2 plus a constant. Because remember, when you took the derivative, you would multiply by 2. So when you're doing the integral, you're going to divide by 2. No, don't do 5e to the 3x over 3, because this isn't a polynomial. This is e. Okay, so remember the integral of e to the kx is just e to the kx over k. So the integral of e to the 2x is e to the 2x over 2. Because remember, what's the derivative of e to the x? E to the x. And the integral of e to the x is e to the x. So it never changes. So the only thing this is doing is adjusting the constant. All right, and then I tell you f of 0 is a half. So 1/2 is 5e to the 0 over 2 plus c, because when you plug in 0, that becomes 0. And what's e to the 0? E to the 0 is, because anything to the 0 is 1. So this is a half is 5 halves plus c. c is negative 2. Because 1/2 minus 5 halves. And now, we go back to the equation, and we plug in minus 2. So you get 5 e to the 2x over 2 minus 2. And that's f of x. Okay, one more of these. Remember, when you do the integral, you can always check if you got it right by taking the derivative. So when you get to your answer, take the derivative and see if you get back where you started. So we'll do that in a second. So here, we're going to want to do, well, first we might want to rewrite this as 4x to the minus a half. So then, integral of 4x to the minus a half dx is 4x to the plus a half divided by a half. Dividing by a half is the same as multiplying by 2. So this is 8x to the half, or 8 times the square root of x, plus c. So if I gave you a question like this on an exam, got to give you something you can take the square root of. It's not interesting if I give you square root of 3. Right? So assume x will be a perfect square. Now, f of 1 is negative 5, so that means negative 5 is 8 times the square root of 1 plus C. Square root of 1 is 1. So C is negative 13, and therefore f of x is 8 radical x minus 13. Let's check that. Let's take the derivative of that. Well, what would the derivative be? It would be 8 over 2 root x. The derivative of negative 13 is 0. And 8 over 2 is 4. So you get 4 over the square root of x, which is exactly what we had. Okay? If we went back to 5e to the 2x over 2, if you take the derivative, you should get back to 5e to the 2x in each one, okay? So as I said, one way you check that you did the integration correctly is do the derivative when you're at the end and see if you get back where you started. And I said, as opposed to where you do multiple derivatives, we don't do multiple integrals. Okay, so where does this stuff show up? These things actually show up in business when you take economics. Derivatives give you marginal cost or marginal revenue. So I don't know if you know what marginal cost or marginal revenue are yet. That's the cost or the revenue. So let's just stick with cost. So marginal cost is the cost of making the last item that you're manufacturing. So if you're manufacturing refrigerators, and you make 1 million of them, it's the cost of the millionth refrigerator. So it's the last one that you're making, because remember the startup costs. You really want to know, once you're making lots of refrigerators, what does it cost to make one? And it helps you figure out the change in the cost of the refrigerator. The change in your costs as you go from making 1 million to 1,000,001 refrigerators. Marginal revenue is the revenue you make from the last item. Okay, so imagine you having your refrigerator manufacturing plant. First thing, you have to build the factory. You have to buy the materials, you have to hire the workers, you have to do the training. So there's lots of costs that go in. So if you were an accountant, the cost of the first refrigerator is huge because you invested all those millions in the plant. But as you start to sell more and more refrigerators, the cost per refrigerator drops. Okay? So marginal cost is a derivative. Now if you want to find out the total costs and you have the marginal cost, you go backwards, and that's what integrals can do for you. For example, we'll show you why that's true. You have some line that looks like this. It doesn't matter what that is. And here you have the total number of refrigerators. Okay, so you're selling your refrigerators. So this is just a number. And here you have the marginal cost. So this is the dollars per refrigerator. Okay? That's how many dollars you spend per refrigerator, or euros, or yuan, or Swiss francs, or whatever currencies, doesn't really matter. So if we did the area under here, and you pretended it's a rectangle, then on this side, you've got dollars per refrigerator. And on this side, you've got refrigerators. So when you multiply those together, what happens to the units? Well, the fridges cancel, and you're just left with total dollars. So an integral helps you, we're going to do more of this later in the week, helps you find the area underneath that curve. And that area is the total dollars. If this were marginal cost versus refrigerator versus marginal revenue, we would give you your total revenue. It does all sorts of things. If this is miles per hour and this is hour, you end up with miles. So if it was a physics problem, you could get total distance. So the integral helps you find the total of something, among other things that an integral can do. So suppose we gave you a problem. You say, wow, that's really scary. How am I going to do this? Let's see. We have got a company is manufacturing those water bottles. Which every week we seem to get another one in this class. If they were living, I would know what's going on, but since they're inanimate, I don't know. Okay, so let's say that the marginal cost of producing the nth water bottle, or the xth water bottle, is x cubed minus x. That's an unrealistic function. Find the total cost if we know that the fixed costs are $7,000. So this is the kind of thing you actually might want to know about someday, because some of you might go into business for yourselves. So if you decide you want to sell something, you want to go online, you want to sell something online, you have an upfront cost, and you're going to want to figure out what your cost function is. That's one of the joys of software and emails and all sorts of electronic things. The startup cost is pretty much the only cost. The cost of sending 1 million emails versus the cost of sending 100,000 emails is essentially negligible, which is why you have spam. Okay? It doesn't really cost a lot of money to send you 100 million emails about whatever nonsense they send you emails about. Okay? And for us, the only cost is the time in deleting it. There's server cost and all those kinds of things. That's very minor. That's how, I mean, the old days, if you wanted to mail 1 million letters about something, it's very expensive to do, but email is not expensive at all. So all you would do is, this tells you the fixed cost is $7,000. Is a way of saying that the cost of making no water bottles is $7,000. The startup cost is $7,000. So now we would integrate this. We get x cubed minus x dx. We're going to use the unfortunate letter c, but whatever. So that's x to the 4th over 4 minus x squared over 2 plus a constant. And now c at 0 is 7,000. So 7,000 is 0 to the 4th over 4 minus 0 squared over 2 plus c. So c is 7,000. It doesn't always work out that this will turn out to be the constant, like it didn't here, so be careful. And that tells you, therefore, that your cost function is x to the 4th over 4 minus x squared over 2 plus 7,000. That's unrealistic because the costs go up very fast. It says you have a crappy manufacturing process. Costs should drop as you make more and more of them until you reach a point where you have to have a second factory, then costs shoot back up again and then come down. So you think of a company like Samsung, which makes a zillion different things, okay? They can have one factory can crank out 25 million Samsung Galaxy phones, but at some point they need a second factory. The cost goes up again. That's why you limit the production model, or you charge more. All right, let's have you guys try one. If you went to the bank and you wanted to borrow money because you wanted to manufacture these things, they would want to know, what are your startup costs? That's the same as your fixed costs. What are you stuck with even if you don't sell anything, just to begin your process? And as I said, this isn't just manufacturing. You want to put up together Stony Brook. First thing you have to do is you have to build Stony Brook. In my youth, they spent a long time building all these buildings. This is a new one, but I moved here I was 2 years old, But between 1957 and 1962, there were no classes here because first you needed 5 years of just physically building the buildings and hiring the faculty and getting all the accreditation and all that stuff. So there are upfront costs to all sorts of things. Okay, if you want to send a space shuttle into space, that's why we did the space shuttle, because we said once we made one, which cost $1 zillion in research and development, once we had a space shuttle, then if you could reuse it, it was cheaper the second time you sent it up. Not a lot cheaper, it was still billions of dollars, but cheaper. As opposed to the Apollo missions, they sent the rocket up and then that was it for the rocket. You didn't use it the second time. Okay? If you think about airplanes, depending on the airline you fly, if you fly some other country's airlines, some of those planes are 40 years old or more, and they're still in use. So the upfront cost of manufacturing the plane is long gone. Now it's just maintaining the plane, which is not cheap. I don't know what a jet plane costs these days, but it's not a small number. Certainly hundreds of millions of dollars. All right, so fixed costs are $6,500. As I said, that's the cost if you've done nothing. You just get it going. If you've sold no items. If you manufactured no items. So you do the integral of 4x minus 8x cubed over 3 dx, which is 4x squared over 2 minus, sorry, there's no 3 there. I hallucinated that. Minus 8x to the 4th over 4 plus a constant, which can be reduced to 2x squared minus 2x to the 4th. This is unrealistic because this is over time your cost will drop to 0, which doesn't make any sense. Marginal cost can come down, but 0 is hard to do. Now, f at 0 is 6,500, so that says 6,500 is 2 times 0 squared minus 2 times 0 to the 4th plus c. So c is 6,500. So your manufacturing cost is 2x squared minus 2x to the 4th plus 6,500. Okay? So far, so good? Let's have you guys do one more. Okay, this is a fun one. Changes over time. Expressed as a percent. Is okay. First, ask yourself, does that make sense? Should you become less efficient over time? Or should you become more efficient over time? I don't know, we'll find out. So, maybe there's an optimal amount of time for your efficiency. So let's see. Find the efficiency in terms of time given that E at 2 hours is 72%. And find the efficiency at 3, 4, and 5 hours. Okay, so the efficiency, dE dt, is 30 minus 10t, so we're going to need to integrate 30 minus 10t, and we get 30t minus 10t squared over 2 plus a constant. Also known as minus 5t squared plus 30t plus c. So that's an upside down parabola. Okay, that's our efficiency. And then efficiency at time 2 is 72. So 2 is negative 5 times 2 squared plus 30 times 2 plus c. 72 is, that's 60, minus 20 is 40, plus c, c is 32, which means you start out with an efficiency of 32, yes?
Would it be up 0.72?
Yeah, that's what.
Oh, well, yeah, but I did it as a percentage. You guys made life too hard to them yourselves if you made it as a decimal. Sorry.
So if we made us decimal, could we leave it or shouldn't we?
I would leave it, I would make it 72, I wouldn't make it 0.72. The numbers are probably awful. Right? Sorry about that. So that means our efficiency equation becomes 30t minus, oops, down here, minus 5t squared plus 30t plus 32. Should have told you guys it wasn't decimal. We're well trained though. All right, now you just have to plug in 3, 4, and 5. So see, that's what the phrase expressed as a percent meant. So E is minus 5 times 9 plus 30 times 3 plus 32 when we are at 3 hours. Which is 77. E at 4 is minus 5 times 16 plus 30 times 4 plus 32, which is 72. Efficiency's dropping, which makes sense. Too many hours in the machine. E at 5 is minus 5 times 25. Plus 30 times 5 plus 32, which is 57. So let's see, at 3 hours we were at our maximum, well, we were at our best efficiency out of those 3. The maximum efficiency, well, remember maximums where the derivative is 0. That derivative is 0 at 3 hours, so that's where the maximum efficiency would be. Okay, so you can use this information to find all sorts of fun stuff. I have a very sleepy class today. Is it the whole daylight savings time? Is that throwing you guys off? All right, so I have one announcement. It's possible I won't be able to have class this Wednesday. I know that makes you sad. I will know tomorrow. We're certainly having it on Friday, but I will make an announcement if we're canceling for Wednesday. Okay? Bye.